G'day, Year 11s. All right, let's jump straight into it. Today we are looking at the simplest situation where you are given a linear graph and you are asked to find its equation. Now this is called the intercept-slope method, okay? This method only works when there is a very, very clear y-intercept, all right? And you can look at the y-intercept, you can physically look at the graph, look at where your graph crosses the y-axis, and you know without any doubt exactly what that y-intercept is. Okay, so basically when it's a whole number. This method doesn't work when your graph the part that intersects the y-axis is not shown on the graph. Okay, so your graph is truncated, it's chopped short. Or if your graph intersects the y-axis at a sort of random spot, let's say somewhere between y equals 2 and y equals 3, and you can't know for sure whether it's y equals 2.3, y equals 2.31, y equals 2.32, you just don't know, okay? So we're looking at the situation where it's very clear that the graph intersects the y-axis at a very specific point. All right, so to use this method, there are to get your equation for your linear graph, there are three very simple steps. Number one, you note the y-intercept because this is going to be your a value in y equals a plus bx. You choose 2 points on your graph, any 2 points, okay, but we like to try and be clever and choose points that have whole numbers for their coordinates. That makes the maths easier, okay? And the problems that you're going to do in the textbook are usually set up so that you can make this choice, so that you can choose whole numbers. So you choose any 2 points on your graph, and for each one of those points, you get a set of coordinates, an x and a y. So with 2 points, you'll have an x1, a y1, an x2, and a y2, and then you substitute them into the rise over run formula, y2 minus y1 over x2 minus x1, and you will get your gradient. So that's your b value. So steps 1 and steps 2 allow you to find a and b, and step 3 simply says, chuck all this stuff together, substitute a and b into y equals a plus bx, and you will have an equation. All right, so let's dive into it. Sorry, I need to scribble out what I've written here. That was from a previous video where I completely stuffed it up. So professional, Sean. All right, here we go. So on the left here, determine the equation of the lines in the following graphs. Question A. All right, the first thing that we need to do is take note of the y-intercept, which is minus 3, because that is going to be our a value. A equals minus 3. So far, so good. Now we need our b value. So b is the gradient, okay? So I can either identify 2 points on the line, write the coordinates for those 2 points, and substitute those coordinates into the formula y2 minus y1 over x2 minus x1. Or in a really basic example like this, I can cheat a little bit. That formula really is just measuring or determining rise over run, okay? And I can see that this graph intersects this point here and this point here, all right? So what I'm going to do is draw a right-angled triangle. This would work connecting any 2 points on the graph, by the way. There's nothing special about those 2 coordinates. And I'm just going to count up from here to here to see what the rise is. So it's 1, 2, 3, 4. And the run is from here to here. The run is 1. So rise over run will be 4 over 1. Okay. Now, if the gradient of our graph was negative, that's to say if our graph was going downhill from left to right, we would need to put a negative sign in front of our gradient value. All right, So let's set out the algebra now. Okay, so B is rise over run, which is 4 over 1, which is 4. Dead easy. Now all we need to do is substitute our A and our B values into the general slope-intercept equation, y equals A plus bx, and we'll have our equation for this graph. So, substitute A equals -3 and B equals 4 into y equals A plus bx. So y equals A plus bx becomes y equals -3 plus 4x. Full stop. That's it. That's our equation. All right, let's do one more example. So now we're going to actually use the gradient formula properly. All right, step number 1 is to take note of the y-intercept. The y-intercept here is clearly y equals 2. So that's our A value. A equals 2. All right, now to use the gradient formula, we need 2 points on our graph. Now I'm going to select 2 points that have whole numbers for coordinates so that I know that I'm getting an exact answer. So if you look carefully, this point here also has whole numbers for its coordinates. All right, so let's zoom in and add those coordinates. This point here is 0, 2. This point here is 2, 1. What I'm also going to do is label these x1, y1, and x2, y2. Now you might be thinking, could I have done that the other way around? And the answer is absolutely. This coordinate here, you could have labelled those two numbers as x2, y2, and these two numbers as x1, y1. It would not make any difference to the answer whatsoever. All right, so we have 4 numbers, which is what we need. B equals y2 minus y1 over x2 minus x1, which equals, all right, so y2 is 1. So 1 minus y1, which is 2, over x2 minus x1. Well, that's 2 minus 0. And if I simplify this, I get 1 minus 2, which is -1. And 2 minus 0 is 2, so -1/2. So that's steps 1 and 2. Step 3 is to simply put our A and our B values, substitute them into y equals A plus bx. So substitute A equals 2 and B equals -1/2 into y equals A plus bx. So we get y equals 2 minus 1/2 x. All right. Thanks, guys. Quick one today. I will see you next time.